Welcome to our in-depth session on handling date and time in JavaScript. If you have ever worked with dates in software, you know they can be a source of constant frustration. Time zones, leap years, and disparate formats make this one of the most complex domains in programming. However, JavaScript provides a built-in date object equipped with a suite of methods to tame this complexity. Today, we will explore 12 essential functions that you will use daily to parse incoming data, format dates for user interfaces, and perform precise time calculations. We will clarify the confusing zero-based indexing of months, the difference between calendar days and weekdays, and the modern, performant way to internationalize your dates. By the end of this module, you will have the expertise to manipulate time with precision and confidence, avoiding the common legacy traps that catch many developers off guard. To begin working with time, you first need to instantiate a date object. The constructor is versatile. Calling it with no arguments captures the exact moment of execution, the now. If you have a specific date in mind, like a birthday or a deadline, you can pass a date string in the standard ISO format to create a static snapshot of that time. But here is a pro tip for performance. If your goal is simply to measure how long a function takes to run or to create a unique ID based on time, you do not need the overhead of the full object. Instead, use the static method date.now. This returns the raw timestamp, a simple integer representing the milliseconds elapsed since the Unix epoch. It is lightweight, fast, and often exactly what you need for system-level timing logic where human-readable formatting is not required. Once you have a date object, you often need to extract specific components, and the most common is the year. The method getFullYear is your reliable tool for this, returning the 4-digit year, such as 2025. It is crucial that you strictly adhere to using this method and avoid the legacy getYear function found in older tutorials. That outdated method returns the year minus 1900, meaning for the year 2023, it would return 123. This archaic behavior is a relic of the early web and a frequent source of Y2K-like bugs in modern applications. By consistently using getFullYear, you ensure your application logic remains clear, accurate, and future-proof, avoiding the need for manual addition to correct the century. Extracting the month introduces one of the most infamous quirks in JavaScript. When you call getMonth, you might expect a number from 1 to 12. Instead, you get a zero-based index where 0 represents January and 11 represents December. This design choice, borrowed from older languages like C and Java, causes endless confusion for beginners who try to display this number directly to users. If you print 0 for January, your users will think your software is broken. Therefore, whenever you need to display the month numerically, you must remember to add 1 to the result. However, this zero-based index is actually useful when working with arrays, allowing you to use the result directly to pick a month name from a list, without needing to subtract 1 first. Moving down to the day level, we encounter the getDate method. Despite its somewhat ambiguous name, this function strictly returns the day of the month, the calendar number ranging from 1 to 31. It is important not to confuse this with the day of the week, which is a completely different concept handled by another method. You will use getDate whenever you need to display the specific date on a calendar UI, check if a billing cycle has ended, or calculate the number of days remaining in a month. It handles the variance in month lengths automatically, so you always get the correct calendar integer for the date object's stored moment. Just remember, getDate gives you the date, as in the 23rd, not the day, as in Wednesday. In contrast to the calendar date, getDay reveals the day of the week. Like the month function, this returns a zero-based index, but here the week starts with Sunday as 0 and ends with Saturday as 6. This means Monday is 1, Tuesday is 2, and so on. This numeric representation is incredibly useful for scheduling logic. For example, if you want to disable a submit button on weekends, you can simply check if the return value is strictly 0 or 6. You can also use this index to map to an array of weekday names in your application's language. Just be aware that in some international locales, Monday is considered the first day of the week, so you may need to adjust your mapping logic depending on your specific regional requirements. Beyond dates, the date object encapsulates precise time down to the millisecond. You have a suite of granular methods to extract these components. GetHours returns the hour on a 24-hour cycle, GetMinutes and GetSeconds provide 0 to 59, and GetMilliseconds offers 0 to 999. These are indispensable for building clocks, countdown timers, or timestamping user actions. Be mindful that these methods return the local time of the user's system by default. If you are building a global application and need to coordinate events across time zones, like a scheduled meeting, you should look into their UTC counterparts, such as GetUTCHours, to ensure everyone is referencing the same absolute moment regardless of their location. Underneath all the formatting and calendar logic, a date object is just a wrapper around a single number. The getTime method reveals this fundamental truth, returning the Unix time, the total count of milliseconds that have elapsed since midnight on January 1, 1970 UTC. This large integer is the universal language of computer time. Because it is just a number, it is perfect for mathematical operations. If you need to compare two dates to see which is later, checking if date A getTime greater than date B dot the time is the most performant and accurate way to do it. It is also how you calculate duration. Subtract the start time from the end time, and the result is the exact elapsed milliseconds. This is the bedrock of time manipulation. JavaScript date objects are mutable, meaning you can change their state after creation using the set methods. Functions like setFullYear, setMonth, and setHours allow you to adjust specific components while keeping the rest of the date intact. This is powerful for logic like move this subscription renewal to next month or reset the time to midnight. However, this mutability is a double-edged sword. These methods modify the object in place. They do not return a new copy. If you pass a date object to a function that modifies it, that change is reflected everywhere else in your app that references that object. To avoid side effects, it is a best practice to clone the date first before applying these mutations. When it comes time to send your date data to a server or store it in a database, consistency is key. You cannot rely on local formats like 10252023 because they are ambiguous. Is that October 25th or the 10th of the 25th month? The toISO method solves this by converting your date into the ISO 8601 extended format. This string always looks like YYYY-MM-DD-THH:/MM:SS.SSSZ. It is strictly standardized and always in UTC. This ensures that no matter where your server or users are located, a moment in time is preserved without time zone confusion. It is the gold standard for data interchange in modern web development. While ISO is for machines, humans need dates in a format they recognize culturally. The toLocale-DateString method is your bridge to the user interface. By passing a locale code like ENUS for American English or DED for German, the method automatically formats the date string to match local conventions, placing the month first for Americans or using dot separators for Germans. You can further customize this with an options object to specify whether you want the full month name, a numeric representation, or the weekday included. This abstraction saves you from writing complex switch statements to handle internationalization manually. For applications that need to format thousands of dates, perhaps in a large data table or a list of transactions, calling toLocale-DateString repeatedly can be a performance bottleneck because it has to look up localization data every single time. The modern solution is the International Date Time Format object. By creating a single formatter instance with your desired locale and options, you cache that expensive lookup work. You can then reuse this formatter's format method on as many dates as you need with incredible speed. This is the professional way to handle date presentation in high-performance applications, offering both the flexibility of localization and the efficiency of optimized code. Finally, we address the common task of converting a string back into a timestamp. The date.parse static method attempts to read a string representation of a date and return its Unix timestamp. While it works reliably for strict ISO 8601 strings, it can be unpredictable with other formats depending on the browser implementation. Because of this inconsistency, relying on date.parse for user-generated input is risky. For robust applications, it is often safer to parse the string manually if you know the format, or simply pass the string directly into the new date constructor, which handles standard formats more gracefully. Or, for complex parsing needs, lean on established libraries like datefns. We have now navigated the essential landscape of the JavaScript date object. We covered how to create dates and the importance of using timestamps for performance. We learned to extract components correctly using getFullYear and the zero-indexed getMonth while distinguishing between calendar getDate and weekday getDay. We explored precise time retrieval, the universal truth of getTime, and the mutable nature of setter methods. We also established best practices for data exchange using to ISO string, human-readable display with to-locale date string, and high-performance formatting with international date-time format. Mastering these 12 functions transforms date manipulation from a source of bugs into a reliable, robust part of your development skill set.